Hello everyone. Today's topic is animation. In fact, I will include also two other features in this video which are not really animations, but they are somehow related, and for the sake of completeness I will mention them here as well. One feature is iter path, which is described in the definitions video, and so if I enable it, you can see how the sequence of iterated complex numbers develop outside the Mandelbrot set and inside. Here you can see that it's stable and so on. You can come close to the edge and see the interesting structures. So this is one thing that I wanted to mention. And the other thing is Julia scans. I use my right mouse button to define the path of a Julia scan. Then I enable the Julia figure. I choose 200 points and I execute the scan, and you can see the different Julia sets at the different waypoints of the scan. So, okay, we are done. I disable Julia, and now we come to the real animations. The first thing is rotating the color map continuously. This I will, to demonstrate this, I will revisit our Valley of Elephants, and I think I go here, maybe one more magnification. Don't like the black dots, increase the iterations, and then I choose a different color map prism. Apply smoothing, and I start to rotate the color map. So you see how the color is flooding into the structure very nicely. You can reverse the direction. Now it's flowing outside, and you can increase the speed. This number is the increment when I change the index of the color map within the loop. And here is a wait time, which is also used inside the loop. And if I choose larger values, it slows down, and if I choose lower values, it speeds up. So this you can use these two parameters to control the rotation of the color map. Okay. And I can move through the Valley of Elephants. I can zoom in and still rotation, and I think I really like it. Okay, I stop the execution here, and then I would like to show you the spirals. Here's the spiral, and change the color map, and apply smoothing, and we start to rotate. Okay, I think this also looks nice. And then we can think about these bands. Yeah, so I set every second color to black, and this shows us the spirals very nicely, I would say. Problem is the speed, of course. So we might reduce the speed a little bit, and if we set the increment to 2, then the bands no longer move. Yeah, of course. Yes, so this is what I wanted to show you about the rotation of the color map. I will stop here, and then I come to animated zooms. Okay. So first we zoom into an interesting area, maybe here to this small copy of the Mandelbrot set, and then go here maybe, and then here, and further zoom in. I don't know. Okay, you go here, and that's it. Okay, now clicking on exec will do this animated zoom. Okay. If you want to make it faster, you reduce this factor and to slow down, you make it bigger. Okay, I can stop, and maybe now to this place here. Okay, and now we can make spiral zooms, and we can choose the number of turns. And then we start. Now, this debugging figure appeared on my second monitor. Here you can see the path, the spiral path. If I choose 3 turns, I get this. Maybe that's too much rotation, but this depends on how long you zoom in. If you choose -1, you have just a linear path towards the target. Okay. So if you select 0, you just move to the target and zoom in. Okay. Now during the animation, you see that the width it changes from 1000 to 500. Let me show you. Okay, here we are at 500. This makes it easier for the computer, and we can zoom in faster by a factor of 4. If you don't like this, you can disable this feature and click on Animate Uses Constant Width. Then we stay with 1000. I'll show you. Okay. And then there is a problem with these animations when we have a big part of the Mandelbrot set in our region of interest. Then we slow down because the computer has to calculate the iteration for a very long time. And for this, I to speed up, I use a convergence test. The idea is that for numbers in the Mandelbrot set, the sequence, the iterated sequence, converges quickly to some value. And then I say, okay, if I find that I find this convergence, then I will assume that the number C belongs to the Mandelbrot set. This is not really always true, and this generates an artifact, which we might see in a minute, but this speeds up the calculation. Okay, then I apply this convergence test, and now I have to, before I can zoom, I have to choose something where I want to zoom. Okay, and now we zoom. So then we cross this large area of the Mandelbrot set faster. This is the idea of this flag. But it can create some artifacts, blobs. Maybe we see them in a few seconds. So now we go to a different place. I wanted to show you interesting structures which appear when one zooms in. So here you have a narrow connection between two larger structures, and if I just zoom in, we are at 10 to the -8, so there's enough room left. Now we are at 10 to the -12, and then we can maybe adjust the colors a little bit and zoom in. Okay, here we have the narrow connection, and for me it seems as if I drive towards this point, and then these structures are flying towards me. I think it looks really nice. So animated zooms allow you also to change the target during flight, and this can be nice. I can show you this effect. Go to the structure, make a few clicks on this narrow connection, and then change my target, and then follow this extension, peak, whatever. So you will see how it looks. So this is the target still. And at some point we will change the direction and go here. I think this looks cool. This is what I wanted to show you about animation. I hope you enjoyed the video, and I thank you for watching.